Unit 4, Part 3 of 4.2. We're still looking at how the data is spread, but not just how far apart they are spread, also how they are spread around the central values. So in this section we're going to look at variance and standard deviation. Which is like basically the same thing, one is just the square of the other. So this tells me how far the data is spread out around the mean. Okay, let's look at an example. How tall is each person in a family? And I'm going to do it using a sketch. And we're going to have baby here. We're going to have a 5-year-old. We're going to have mom and dad. And I'm going up in half meters. So 0.5, 1, 1.5, 2. So baby is half a meter. The 5-year-old is 1 meter. Mom is 1.7 meters. And dad is 1.9 meters. Now, what we're going to do now is we're not going to look at a line of best fit. We're going to look at the mean. So the mean of their heights is, add them all together, divide by 4. And it gives you 1.28. So 1.28 may be around here. So there is my mean. Now, what we want to look at is, in this case, baby is below the mean. So baby is negative 0.78 below the mean. The 5-year-old is below the mean, negative 0.28. Mom is above the mean, so it's positive 0.42, and dad is above the mean, so it's positive 0.62. And we are going to have a look, in other words, at how my data is spread around the mean. So the standard deviation we indicate with this little sign, which is the lowercase sigma Greek letter. And it tells me how all these heights are spread in relation to the mean. Right, and variance, as I told you, is pretty similar because variance is just your sigma squared. It's your standard deviation squared. Right, now how to find them is you're going to use your calculator, and the same as previously, I'm going to say depending on which calculator you have, it's different steps you take. So look in the book, the little book attachment to your calculator, or go and look on the internet to figure out how to find the variance and the standard deviation and practice it. Let's just see why is it important? Why do we need this? So let's say I have the mean score for a class test. So of all the students, the mean score was, remember mean is x bar, was 85%. Let's say also that when we worked this out, in other words, we took all the data, all their marks, we found the mean, we also found the standard deviation, and it was 8.1. Now compared to 85%, that is small. What does that mean? Most students actually scored close to 85%. So your marks are all clustered quite close to 85%. But on a different one, if we look at the heights of our family above, this example we did there, the sigma is 0.56. Now if you compare that to the mean, then it counts as large, which means the family's heights are spread widely around. And that's clear if you think of a family. Surely the dad is much taller and the baby is very small. So the data is not clustering close to the mean.